And we are live. All right. Hello, welcome. Just gonna post real quick that we are live, and then we can already get started for today. Maybe in the meantime, you can already let me know if the background music is good, if the volume's good. Well, awesome that you're joining from the gym, and thank you so much for the congratulations. Yeah, it's been a long time coming. Very excited, and also very excited that we could finally talk about our customers, which I've been burning to do for a while. It's been a really awesome journey with them. Hello, Nicholas. Welcome back. Thank you very much. Now it's easy for everyone to get started and do what we do on this stream, right? That's the whole point. Yeah, we've had pretty cool reception already. We had a bunch of people sign up and try out the product, give us feedback. We got a ton of really awesome feedback on Hacker News, on Twitter, everywhere. Yeah, it was really awesome. Super happy with it. All right, cool. I guess then we can get started. If this is your first time on Let's Profile, this is the Let's Profile stream where we take some open source software, ideally some that we run at Polar Signals, so that we can get real production profiling data that we grab through our product and then share on, and let me share my screen now, that we share on the system called pprof.me, which we host, where you can just kind of share any query that you do in Polar Signals Cloud and can share it with your team. It will never go away, and you can put this onto a GitHub pull request or wherever you want to. Oops, there's something off with my camera view here. Okay, it's fixed. So yeah, and today we'll be looking one more time at the Kubernetes Kubelet. Depending on how today goes, maybe this is where we'll finish up on the Kubernetes series. But if you have any suggestions, again, ideally we run the software that we optimize in production at Polar Signals. Here I see in chat that maybe the music. Okay, let me. Turn it down a little bit. Let me know if that is better. So yeah, if you have any suggestions of what we should profile next, let us know, and you know, we can try. Today we're going to be looking, like I said, one more time at the Kubernetes Kubelet. There are a couple of paths that we have already optimized. Maybe we can quickly go back to those, and I'm going to just drop the profiling data in chat here if you want to follow along. But basically what we first optimized was I think something like this. Yes, exactly. We optimized all of this regex compiling and matching away. That was the first one. That was pretty nice. Actually, it was not just optimizing away this regex compilation, but also what happens afterwards. So I think we optimized about 2% of the kubelet CPU time away with that. Then last time we optimized, oh gosh, I'm already starting to blank. I want to say we optimized something about reading U64, something like this. Oops. Yes, this is the path that we optimized last time. Of course, we couldn't get rid of completely optimizing away the reading a file. This still needs to be done. But then there was one more really awesome contribution from one of you, and huge shout out for that. So let me pull that pull request up real quick. That was this one. And I believe you're in chat, right? So this was an additional improvement where basically my understanding is we can skip reading a bunch of files that was really expensive to do when we don't truly have to. So yeah, super awesome contribution. Do you have a guess of how much this is going to optimize away in terms of this profiling data? Or is it hard to say because we don't know how many of the open calls or stat calls were unnecessary? I think you mentioned in the do you have a measurement of how much faster you think this is going to be? Not super easy to say. Saw half stat calls were errors on C groups V1. I mean, you know, let's say for a second that half of the calls here in this would be saved. That would be 2.5% of the CPU time, right? That would be pretty huge. Depending on where we land today, maybe we'll get to 7% or something like that of CPU time saved in total. That would be really huge, right? So very cool that you took this on. So again, today, what we're going to be looking at is this code path that we already started exploring last time, which is basically we keep recreating a bunch of objects over here, and we can see that a lot of them end up calling runtime.new object. It does some sorting as well, calls make slice. So we do a ton of allocations in this code path, and I believe that we are going to be able to get rid of a lot of these, because the reason why this happens is, and we looked at this last time already, maybe it would be wise to use not our brand from last time for this. Diverging. Did I commit? Okay. There was another comment. If you look at the code, it was trying to read a file within the directory unconditionally. And what you did was that the moment that a directory was not existent, we don't continue with it, right? And therefore preventing further stat calls or further things that potentially are done within that scope that would all fail. So yeah, super cool contribution. I love that we're creating a community of, gamifying these improvements. I love it. That's exactly what we want to achieve here. And ultimately we're making the world a little bit better by saving everyone some CPU cycles. That means servers use either less electricity or they have more space for workloads. Either way, it's only better if we're not doing something unnecessary. So could not be more excited about this. As always, let me know if the font is not large enough. I'll leave it at this, and then let me know in chat if I should change anything. But let's dive in. So we had this file, and we already saw that basically we need to figure out these labels, and we need to create essentially a key to figure out has the set of label names changed since the last time we gathered this information. And judging by production data, this happens incredibly rarely. Actually, I wish I could pull up production data now, but basically, I've looked at this, and these labels are incredibly stable. So what does that mean? Let's so this is injectable. This returns a map of string. So we can mock that for sure. Because what we want to do is we want to build a benchmark for this. And I think we started last time already. I think I might have just reset the benchmark we started writing last time, but it was probably not what we wanted to do anyway. So let's just start from scratch and we'll do benchmark Kubernetes Kubelet. And can we set the container label func? Yes, we can. That's awesome. So we create our new collector. The new Prometheus collector, and info provider does what? Okay, let's see, what do the others do here? Aha, we can do this. We change this interface. Now we can change it to assert dot. Oh. Ah, this is my setup fighting me. A very, very subtle difference between my OS X setup and this is my Linux machine. What is it saying here? Wrong signature. I see. Okay. Oh, I don't know what I was doing this. I just want this. All right. And mock label func. Okay, that just doesn't return anything. That probably we want to fill with something. And what is now? Now is a mock time. Okay, and up docker. Okay. So I think I'm pretty okay with this as is. Now I'll quickly hide my screen and grab some production labels. Just from any metric from cAdvisor. Plus right now. No, it wasn't. For some reason the UI wasn't loading. So container CPU settings total, for example. Let's see. Yeah, I quite like this one. Cool. All right, so let me open that again now. Back to our scene. All right, so I have example set of labels here. So we've got the alert manager. It has the container, and that's labels equals string. So we have container equals alert manager. Endpoint is a target label, so we'll skip that one. image. And we can delete these as we take care of them. Instance is also a target label. Job is a target label. Metrics path is a target label. Name. And then the space is one as well. And pod. All right, so now we have our label set. All right, and we can replace our mock label func now with what was the signature here? This. All right. Label func. All right. So now that we have that, we can. What was the? We call collect. Collect is the expensive one. Yes. Yes. Okay. All right. So. So then we create a channel. Yep, that is exactly the kind of channel we want. And then we will create a context. We defer this, and then we run a go func. Nicholas, you're asking about the playlist. Actually, the playlist is in the description below, so you can just check it out there. There are already being their credits in the description. But glad you like the playlist. All right, so now the dot Kubelet. No worries. Oh, here we go. Okay, so now we can reset our timer and we run our benchmark. This should be it. Let's see. So, go test run, our good old trick, ignoring all other. Whoops. I always do this now. I guess. I don't know if there are any other benchmarks here. We'll see. We run it 5 times and then we key equal 2. right, we've got a deadlock. Let's see what we did wrong. But it does look like this is the only benchmark we have here. So I prefer being exact. So of course the same thing should happen. All go routines are asleep. Now, why is it happening? It is trying to we're probably sending and not receiving from the Indigo routine. Oh no. Classic mistake. We exited after the first iteration. Couldn't get version info not supported. What is that? Okay, let's see. That's of course something about our mock info provider. Okay, looks like I wonder if this is going to change other tests, but let's see where this was used otherwise. That looks fine. Okay, I think it's safe to change this and return info. And maybe we can even find out. Okay. Maybe we'll leave this empty though. All right. So looks like we're gonna start to get our baseline. Okay. So now one last thing. Let's actually create some CPU profiling data as well. Okay, so now our good old friend pprof me that opened in my other, that and copy here to here. All right, so we've got our benchmark run, and it looks like new const metric is the one that pops up here. So it's not quite identical to what we're seeing. That's interesting. Why is that? Why are we seeing only new const metric and not the other ones? We are in the right place, and this is being called, but not new description. All right, let's dive into the code to see why this might be happening. So select containers info. Get requested containers info, and I think this is just empty. Our mock. Yes, it is. All right. So, then let's add that here, and we info is no string container info, yeah, and we let's make this container info map of string to container info, and that, and here we return m dot container info. So now we can use this mock to actually feed some data. So that would be container info equal string container info. Now what is container info? Let's check that out. So we've got a container reference. Okay, that's the container ID. Got an ID, that's something. So we start with that. No, I suppose this is good. Maybe we actually use a non-mocked version of that, but we'll get to that in a bit. So the ID is this. The container ID. Name of the container. It's alert manager. Aliases we do not have, and namespace is difficult word to write. Subcontainers, we do not have subcontainers. Let's see what this is. Okay, here we've got an image, awesome. So we've got spec, so container spec, and that has image, almost, IO, snap, Prometheus, third manager, 6. Now, hold on a sec. Maybe ID something else. Stats, timestamp, processes, custom tricks. That all looks okay. Let's see what this is. Subcontainers. No, that doesn't look right. ID. Ah, no. All right, let's use this as the name. And we'll figure out what the correct or the normal label function is. Right, like not defined here. So what we're gonna do is we're gonna just take this, do a grep. Okay, not here clearly, maybe here. Manager config file. Interesting. Let's see. No, we want this. Okay, let's figure out. Alright, so it's passed via this function. What? No, just copy this. All right, so resource manager. Okay, interesting. Resource manager has, okay, interesting. Label. Okay, so it's just get container labels, and handler is new container handler. Okay. Container handler. Oh my god, that is a lot of indirections. But what we can do is labels. We just search for okay, that's because it depends on the kind of handler. I suppose that makes sense. So let's just take any of them. Interesting. Okay. 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 And then it sets it on a per. So it creates a handler per container. I guess that makes sense. Okay. Okay. I think this is starting to make sense. But I guess it is also okay. So then it doesn't make sense for us to still mock this. Okay. So we're gonna make sure that we still have this here and name here, and now hopefully our using key in map literal 345. Okay, I see. So, okay. So here we take our ID and then we take our name here. All right. That makes sense. All right. And that number already looks quite a bit higher than what we had last time. So let's look at this profiling data again. I'd open it in my other tab again. So and okay, now we're good. Now we can actually see must new const. Okay, perfect. That is exactly what we wanted. I guess this is showing up a bit more than we expected. Sanitized label name. Did we encounter this here as well? This one, continue. Sanitized label name. See. But I think we're now good. This is probably good enough for us to okay. I suppose this makes sense. That's because we don't. Because we keep rerunning it with a single container, the sanitized label name occurs a little bit like statistically much more often. Maybe it actually still occurs in here. Let's see. Yeah, it does still. Oh, sorry, that's the previous one. Okay, here looks like it doesn't, but I think this is okay. That's just an artifact of us having, you know, a synthetic benchmark. It's not always going to be perfect, but I think this is gonna be much better already. All right, so now we can actually start optimizing. Maybe at this point we can do a quick commit. Collection. Now what we said was if the label names don't change, then we can save ourselves all of these new description calls. So what we are going to do is we are going to first create a key. And our key is a string. Label name. This is not gonna work like that. Can't type today. Gonna be 0, and we're gonna iterate over all of these and do this. And now we're going to pre-allocate our key because we want to make sure that this is all nice and fast, and we just append to this key. Now we can check. There was a comment. The commit reminded me I saw you name in the history earlier as the committer name. Let's go back. Oh, thank you very much for mentioning that. Let's make sure we fix that later. At least the email was correct. So GitHub showed everything correctly. Thank you so much for mentioning. Actually, fix that right now. What is it? Git config that. I gotta Google this. I don't do this often enough. Git config that name. No, perfect. All right, thank you very much for noticing that. All right, so if now what we're gonna do is if we're gonna store this key in our Prometheus collector, label string and label mutex, because this can be called by multiple, like the Prometheus endpoint can be called concurrently, so we need to make sure that this is concurrency safe. And we're gonna check that if previous key label key mutex read block and Yeah, we can do something like that. That sounds good. So if previous key unequals key, okay, we can this is string. And complete descriptions. And if not, we just continue. All right. So that means we create descriptions. Doing descriptions. All right. And we're gonna. Actually, I think I would prefer if we create an object for this. Type descriptions. Now, we want to have a description for start and seconds. Okay, then we're going to just do something slightly different here and say if bytes equal not and previous key the label key a byte slice as well. All right, now we wanted to, so what we would need to do is we iterate over these containers and we create labels. We do this. Don't care about the values for a second. Look at the correctness of this. We iterate over all raw labels. We sanitize them. We check if we already have this label. This actually sounds surprisingly. I would have expected this to show up in profiling data, but okay. And we iterate over raw labels every time for all containers. Interesting. All right. But that means that labels will always be the same. Okay, that's exactly what we wanted. So we can just do this. We get the container labeled. We do this. That sounds good. It's not duplicate. We added, and we have our label. Okay. Okay. Now it says it doesn't know this. That's okay. We'll fix that by adding start time seconds. Use description. What's going on here? Yes, okay, that's fine. We'll fix that in a bit. Now we can replace this with that. Now next one we have is CPU period. Now let's add that one. List new period. Oops. Place it here. All right. Next. Now next one. CPU quota. All right. Did we already do that correctly? Container spec CPU quota. Yeah, CPU quota of the container. Did do it correctly. Description CPU quota. Yes. Now of course we need to add this one as well. CPU quota. Now, next one. CPU shares. Maybe we can first add all of them. Then memory limit. I guess we don't really need bytes in here. Memory what? Memory. Memory reservation. Right, next set. Container metric. What is it? Okay, I remember this. We needed to basically, yes, we need to create the descriptions for the labels This is a slice, so this stays the same. That's amazing. So we can just say container metric descriptions, and it's just a slice of descriptions. So we'll store that in there. And then what do we have here? Custom metrics. Custom metric descriptions. And that's it. All right, so now we can go back and place them one by one. Maybe we go to. All right, so the next one we have is CPU shares. Container spec CPU share of the container. Let's place it here. Share. And memory limit. Container spec memory limit bytes. Memory limit for the container. Memory limit for the container. Yes, correct. Memory. Next one. Memory swap. Container spec memory swap limit bytes. Correct. Swap memory swap limit for the container. Memory swap limit for the container. Yes. Amazing. Memory swap limit. Next one. Memory reservation limit. I think we can name it. Container spec memory reservation limit byte. Memory reservation limit for the container. Memory reservation limit for the container. Yes, gotcha. Great. Okay, so we can place this one as well. All right. Now we get to these. So we take this part, which gets us the description. What's cont? Okay, that's the container. Why does that work? Let's have a okay, interesting. Maybe, just maybe we skip this for a moment and we, what's this? Oh, yes. we can do this once for all raw labels. Perfect. That's what we wanted. Great. And we do actually still need to do this because sanitization potentially could create duplicates even if the raw labels are not identical. So that was a good call from them. That would have been a very weird bug to troubleshoot. All right. Now, I think we can already at this point now we can set the key and description. Lock, unlock, and we set label key to be this, and then the description to be this exactly. All right, and now only when the keys do not match are we recomputing these. All right, so let's try this out. All right, nil pointer on 186. 181. All right, of course we need to initialize our mutex. Maybe not here. Label mutex. Yep, there we go. Did that get worse? We might have made it worse. Interesting. We have made it worse. Why? Let's see. Let's look at our profiling data. Here we go. We're calling new description more often than before. I think I have an idea. The problem might be that we're inserting the label names into a map, and therefore the key may be different every single time, even if the label names are the same, because they're in random order. Let's see. Let's see if that might be the case. So raw labels, yes, that can definitely be the case. So what we're gonna do is label names. Yep, exactly that. And now we can put strings on label names, and we do this, but here we do label names instead. Okay, let's hope for the best. Aha! That looks different. All right, now we are actually in the game. We've improved it by 12%. So let's look at that profiling data. now we can see, yes, exactly what we want. We are basically no longer seeing any of these new descriptions. Amazing. Great. Now I have to wonder something additionally very expensive that happens here, and I don't remember if we have an API for this in the Prometheus client, but it's quite clear that the most expensive thing in doing all of this, in doing the new const metric, is make label pairs. So maybe in addition to the keys, we can maybe, I don't know, label pairs. That would mean for each container, do we have to? I don't think we're going to be able to improve that part. At least not very easily. Okay, so yes, this passes the values. For each container. Let's have a quick look. Is there must const metric? Const metric. Populate metric with make label pairs. Is there another one where we can just pass DTO label pair? Honestly, this kind of feels like an oversight. Let's have a quick look at the total amount of CPU time that's spent in this function. Make label pairs. Oh no, this is not the full profiling data. This is the full. Okay, it looks like it's all within this code path where this is happening. This, I mean, I think we should create a feature request on the Prometheus client Go live, because I think this should be possible. Basically, the Prometheus client is forcing us to do allocations, and that's not great. actually curious. Let's keep that in the back of our heads. Now I wanted to have another look at these container metrics, because if I remember correctly from last time, so these custom metrics, this is basically unused if I remember correctly in cAdvisor, but these container metrics, they do happen. They, I think, are, yeah, here. So we can see them being defined here. So but it looks like the description no, this should actually be just fine. Yes, this is fine actually. So basically we recreate this description all the time, and we could, but the description is always the same. It's actually not dependent on the container itself. Okay, that's great. Okay, nice. So what we can do is container metric descriptions. This description. We iterate over these, and we, oops, for each of them. Descriptions. We create like Prometheus description 0 thing b dot container method. Append. All right, perfect. And now oh my God. Okay, so here we go. Right? Yeah, here we are. So the description is then descriptions. Yeah. Like this. All right, cool. Awesome. Now, let's see. I don't think we configured any of the container metrics in our test, so I don't know if we'll see any further improvement, but in reality, this should definitely still improve further, of course, because we are not recreating the descriptions all the time. How could we simulate that? So we create this. What is included metrics? But we did set included metrics to all metrics. Oh. Interesting. How come this made no difference whatsoever? That doesn't make sense to me. How interesting. Why is this not doing anything? That I don't understand that. Just a quick sanity check. Confusing. Why? Oh. Stats is 0 for the containers. We don't ever even go into this path. That's what it is. This is container info, yeah. Yeah, okay. Mystery solved. That's info, container stats. use that. All right. Usage. CPU. CFS, CFS, periods, docker periods, time, get start, runtime, run periods, correct, load average, and we've got our view stats. All right. However, we are going to want to include this in the. Do we have some examples for all of these? Okay, yeah, first, great. Just copy that. We have some. Memory stuff here as well, maybe? No, probably not. Okay, not a problem. Oh my. Actually, I think if we just demonstrate that we're saving basically all the descriptions, then we're good. All right, let's add to our benchmarking setup so that we can update our old data. So Prometheus has amended into this. Now back this for a second while we run our test. Old. Okay. So now we try again. All right, and now. All right, that looks way. All right, awesome. Now let's have a look at the profiling data. All right, awesome. That is exactly what we want to see. Basically, everything is now completely dominated by must new const metric. That's kind of what we expected. All right, cool. That means that we're basically going to be able to, if we go back to our profiling data from today, that means that we basically have optimized away this entire code path. Basically, this does not occur at all. anymore, which is very exciting. So at least 1.3% in CPU time is going to be optimized away by this. If not more, of course, right? Like this is something that we encounter all the time because what we're optimizing away here are memory allocations. That does mean that we're actually also, in addition to removing this CPU time, means we'll also be relieving the garbage collector. So that means the garbage collector also needs to do less work, therefore also less CPU time spent there. So that part is very hard to put into numbers, of course, but it's definitely beneficial. And one of the rules that we always say in performance engineering: anything that we don't have to do is better than work that we have to do. It's always going to be faster to do nothing, of course. All right, very cool. I guess we're ready to finish up for today and open our pull request. Amazing. Okay, so this is exciting. And it wasn't too difficult of a change. All right, amazing. Let's do it. We're not on a branch, so let's do that. From description. And we have this. What I wanted. All right. No, not. So, is that the package name? Reuse descriptions when label prior to this change, Prometheus description objects were recreated on every collection cycle, even though label names change extremely rarely in practice, perhaps even never on a given machine. This means that we were unnecessarily given CPU cycle benchmarking using the benchmark from the previous commit. We determine we're making collecting at least 23% faster, but based on production profiling data, we relate this is improving the Kubelet's baseline CPU usage by 1.3%. Potentially even more, and it also overrides the garbage collector. Benchmark. add some more explanation here. This is because the benchmark shows that all calls to new description are completely disappearing from profiling data, therefore statistically speaking, reducing the kublets by that much. All right, amazing, and we got it. So let's open. Although, since we is there an easy way to change the author? I think I'm okay. We've got it configured now for next time. So got Prometheus description performance. All right. So we're gonna take our description from here. Metrics. Reduce CPU cycle and then nucleus connection. Reduction to the new data. Maybe we can search directly for this path. This is before. For optimizing. After optimizing. Side note. We believe we can further improve CPU usage here, but we think it requires a new API in the oops. Metric functionality that allows caching of the result of make label pairs. We'll open this patch was created on the fuller signals that's profile 3. All right, and we've got a link to that stream as well. Cool. All right. That's open. Amazing. All right. So that means we've likely improved the kubelet baseline CPU by another 1.3%. So if I'm not totally mistaken, that puts us at, you know, let's round this up a little bit and say it's 1.5%. that means last time it was 0.5%, so we've got 2%, and the time before that, I want to say it was also about 2%. So that means that we have optimized away about 4 and a bit percent of the kubelet's CPU baseline, which I think is pretty awesome. This is a workload that runs probably hundreds of thousands, if not millions or tens of millions of times. So any CPU cycle that we can shave off of this workload is going to be huge for an improvement to electricity usage in data centers. It's going to make more space for our workloads to actually do work. So yeah, all around can only be better. So please, if you like this episode and want to see more, please hit like and subscribe. And that's it for this week's episode. If you have any suggestions of what we should be profiling next time, follow us on Twitter. Write to either polarsignals.io or myself, Fred Branch, on Twitter. And yeah, see you next time. Thanks everyone for tuning in. Bye bye.